Myself Adarsh Agrawal. I am a third year integrated MSc Physics student at IIT Roorkee. So the topic for my today's presentation is 8085 microprocessor and its pin diagram. So let's get started. So first we will discuss about what is a microprocessor. This is a block diagram of a computer system. It mainly consists of three parts. One is input-output devices, one is the memory, and one is the processor. So basically input devices are the devices which are used to give input to the computer, and output devices are the devices which are used to get output from the computer. Input devices are like mouse, keyboard, and output devices are like printer, monitor, speakers, and many more. The memory, which is this has a simple functionality. This is which is to store data and programs. So some example of programs are VLC media player, window media players. These are programs, and example of data is songs and videos which we play in that. Now we will move to our third part of this, which is processor. It is the central processing unit of computer system. All the arithmetical logic operations happen over here. So this is like a heart of the computer system. Some may say it is like the brain of the computer system. So now let us move on. Now let us see evolution of microprocessor. So in 1971, Intel developed Intel 4004 microprocessor. It was a 4-bit microprocessor, which means that 4 bit of information can be fetch, decode, and execute at a time. Then we came to Intel 8085 after some years. Now we are at i5, i7 or i9 processor. So it is about a 50 years of evolution from Intel 4004 to i5, i7, i9, which we use in our day-to-day life, in laptops or PCs. So basically everywhere we do not need i5, i7 or i9 processors. Example as a traffic light control or our washing machines, they do not need i5, i7, i9 processor. i5, i7, i9 processor are very complex and they are very multifunctional, but the traffic lights and other applications just involve some simple functions like changing the colors after some time. So we can use Intel 8085 and 8080 for these purposes. They will be much cheaper also. And also we cannot learn i5, i7, i9 processor directly. So first what we do is first we learn 8085 or processor like this, like 8086 also, and then we move on to i5, i7, i6, i9, which is much harder. But the basic concept remain the same. The concept of the processor is to fetch, decode, and execute. What processor do is it fetches the instructions written in the memory location. It decodes it. Decodes it means it sees what is the meaning of this instruction, and then it executes that instruction. This is the basic functionality which is common in every processors. Now coming to the daily life uses of microprocessor. Whatever we use in our daily life, most of the things contain microprocessor. A general thumb of rule is everything which involves programming includes microprocessor. For example, our TV, refrigerator, washing machine, remote, mobile phones, laptops, these all have microprocessors. You must be thinking why in washing machine we have microprocessor. Actually, when we press the start button of the washing machine, a program pre-installed in the memory section of the washing machine is executed by a microprocessor, and the particular result we see, this is due to microprocessor. Also in remotes, when we press a key, the following output is generated. This is by the microprocessor. Now we will talk about pin diagrams of microprocessor. On to the pin diagram of 8085. Basically 8085, as you can see, has 40 pins, 20 on the left, 20 on the right. We can differentiate them by using the top, this latch, and the clock frequency on which microprocessor 8085 work is 3 megahertz, and it needs 5 volts power supply. We will see functionality of all these pins in the depth. Now coming to the X1, X2 pin, the first X1, X2 pin, these are used to provide clock input to the microprocessor, and this clock is provided through a crystal oscillator. Basically X1, X2 is connected to a crystal oscillator which produces a clock of 3 megahertz. Now coming to this reset in bar, this is an active low signal, which means when we give 0 volt or low signal to it, it activates. So this is used to reset the microprocessor. When we put 0 volt on this pin, full microprocessor gets reset. What we mean by that is the PC contains 000H address. Basically this 000H is a 16-bit address. I will discuss about it later. Now coming to the reset out. So reset out are connected to all the peripherals, external peripherals, and when we reset 8085, through this pin, all the other peripherals also get reset. And the VSS and VCC is used to power the microprocessor. Now coming to the serial control used for the serial data transfer, these two pins, SOD and SID pins. The SOD pin is used to transfer data out serially. We program this using sim and rim instructions, and SID is used to accept data serially bit by bit. And now coming to the interrupts, there are 5 types of interrupts in 8085. They are listed here: trap, RST 7.5, 6.5 and 5.5, and INTR. So what are interrupts? Basically, first we will discuss. Like let us say we have given task to a computer to print some PDF, and now the pages in the printer is finished. So printer need to send a request to the microprocessor to display a message on the screen that the pages in the printer are finished and you need to insert the pages. These requests sent from the printer to the microprocessor is an interrupt. So basically there are 5 types of interrupts, and these are priority. These are arranged as per their priority. Trap is the highest priority interrupt, and INTR is the least priority interrupt. Which means if more than one occurs, the more prior will be dealt first. And INTA bar is an acknowledgement to the interrupt. This is pin number 11. Now the read bar and the write bar. These are also an active low signals, and when read bar is 0 means microprocessor is performing a read operation, and when write bar is 0 it means it is performing a write operation. This is read bar and write bar. Now coming to S1 and S0. When these both are 0 means microprocessor is idle, and when S1 is 0, S0 is 1, it means it is performing a write operation. 1 0 then it is performing a read operation, and 1 1 means it is performing an opcode fetch operation from a memory. Now coming to the IO/M, it is used to distinguish between input and output operation and memory operations. Like when when this port has high voltage, it means IO operation is being performed, and when it is low, it means memory operation is being performed. This is the IO/M port. And now this is ready port. What it does is when it is used to synchronize with the slower peripherals. Like when it is active low, it means some peripheral which is slower is yet to process something, and the microprocessor has to wait. So basically what it produces wait cycle so that microprocessor will wait for the peripheral. Now coming to the ALE. I will explain to you the functioning of ALE, that when ALE is 1, it means the AD0 to AD7 pins are carrying the address, and when it is 0, it means they are containing data. These are known as system buses, AD0 to AD7 and A8 to A15. So first you should know that there is in memory there are 16-bit addresses. And microprocessor transfers only 8-bit data at a time. Hence 8085 is a 8-bit microprocessor. So we need 8 data buses and 16 address buses. So basically, what the developer has done is they have multiplexed address bus and data bus. When we need to transfer our address, we use these 8 and these 8 together to transfer 16-bit address. And when we need to transfer data, then these only 8 are used, and what this is carrying is decided by this ALE. When this is high means 80 to 87 is carrying address. When it is low, it means 80 to 87 is carrying data. So now coming to the bit. I have already discussed system buses. This is 80 to 87 and 8 to A15. And this act as a connection between microprocessor, memory and IO devices. So this is also a block diagram. You can easily understand this. Now coming to the last two pins which are left over here, HOLD and HLDA. Clock out is used to synchronize with other peripherals. It is used in a timing and control unit to transfer clock pulses to everything. Now coming to the HOLD and HLDA bar, it is used for direct memory access. Actually, sometimes the external device has to directly access the memory. Without this, what happens is microprocessor. So the controller has to first interact with microprocessor, and the microprocessor fetches data from the memory and then transfer to the respective one who is asking for the data. From this direct memory access we can do directly. The memory can transfer from memory to DMA controller. So what it is, DMA controller issues some hold signals to microprocessor, and in response microprocessor releases its system buses, and then microprocessor acknowledge hold signal with HLDA, and DMA transfer begins and is terminated by releasing hold signal. Hence perform the direct memory access. Now coming to the review of pin diagram, what we have learned. So in X1 and X2 we know that they are used to get a clock input from a crystal oscillator, reset out all the outer peripherals. When we reset this 8085, SOD and SID are used for serial output and serial input. Trap to INTR, these are interrupts, and these are basically some requests from other external devices. Like when computer gets overheat, the sensor will send a request to shut down the computer. This is also a type of interrupt, and they are prioritized. Trap is the highest priority, INTR is the lowest priority. INTA is an acknowledgement to the interrupt. Now 80 to 87 are address/data buses. They can contain address as well as data. Basically, address is a 16-bit. So 8 are these, and the data is the 8-bit. So we can use this. What differentiates whether this is address or data is ALE. If ALE is 1, these are containing address, else it is containing the data. VSS and VCC, you are not able to see. VCC are used for the power. HOLD and HLDA, as we have discussed, these are used for the direct memory access. Clock out is used in a timing and control circuit. Reset in, when this is active low, microprocessor get reset. Ready, this is used to synchronize with the slower peripherals. IO/MVAR, this defines whether the microprocessor is performing input-output operation or operation on a memory. When it is low means memory operation is performed on a memory. S1 and S0, this defines the state of the microprocessor: idle, it is idle, or it is reading, or it is writing, or it is opcode fetching. Read bar and write bar, this also defines whether it is reading or writing. ALE, I have explained you that when it is 1, then these are containing address, else it is these are containing data. S0, I have explained. A8 to A15, these are address buses. This was all about a brief description of all the pins of 8085. Thank you very much, everyone.